Variance and standard deviation. Just as expected value for a probability distribution is analogous to the mean for a data set, and we've looked at this, the variance and standard deviation, which remember are measures of dispersion for a probability distribution, are analogous to the statistics with the same names for a data set. It can be shown that the variance of x is the expectation of x minus mu squared, where mu obviously is the mean or the expectation for the distribution, which is the expectation of x squared take away mu squared. But we very often write this as the expectation of x squared take away the expectation of x. Remember, the mean is the expectation squared. So it's nice and easy to remember as the expectation of x squared take away the expectation of x squared. The expectation of x squared is the sum over all x of x squared times the probability. So if we just quickly jot down an example, so something like we had before where we had 1, 2, 3, 4, 5, and then we had 0.1, 0.2, 0.4, 0.2, 0.1. We know for the expectation that we did 1 times 0.1 plus 2 times 0.2. For the expectation of x squared, that's going to be 1 squared times 0.1 plus 2 squared times 0.2 plus 3 squared times 0.4, and so on. The second version is generally easier to calculate, and when I say the second version, what I'm talking about is, of course, this one here. It's easier to calculate than this one. The standard deviation, as always, is the square root of the variance. So the standard deviation of x is the square root of the variance of x.